All right, we're live. Hopefully this recording works. If it doesn't, that'd be real sad. Um, so for context for anyone watching this video that is not in the Zoom meeting right now, this will be a high-level overview training of fourth axis CNC milling, but specifically in MasterCAM. I'm assuming that anyone watching this training is already familiar with MasterCAM, so I won't go into depth with the things needed to get going. If we have any questions along the way, feel free to just ask, but I'm going to just jump right into MasterCAM. All right, can you guys see that? Okay, so I'm just going to open up a part real quick. We'll be on the fourth axis, the VF4. The part we'll be using is just a totally random part that I made for practicing fourth axis.
It's
Yeah, Logan knows this part.
I think it's actually.
Go. Oh
I
man.
believe it's the one that's called T.
We could open that up. That would actually be really easy. If this doesn't work, we'll do that.
You just don't have it.
There we go. Okay, so this is a super goofy part. It's got some surfacing over here with the deflated airbag thing. We have some holes we need to drill, some 2D, and then some 2D wrapping. Okay, go through and set this up real quick. First things first, we're going to set up the datum. It's important to note that on our machine, the fourth axis runs about the x-axis, and if you draw an arrow coming out of the fourth axis, it points in the negative x direction. So when you set up your datum, you want your datum to be in the center of the round with that negative x pointing out the front of your stock. I'm going to be assuming that we've already turned down this portion right here, and that's what we'll be grabbing onto. So I'm going to go ahead and just move this part to reflect what I just described. Okay. Good. So this is how it'll be set up on the fourth axis. I'm using the top plane for my home plane. We'll be clamping right here, but we'll use this end as our datum. And again, it's important that you put the center line on that X with negative pointing out of the stock. Let's see. Let's go ahead and delete this thing. Nope, not that. No, we don't need this, but we do want this. Okay. So right here we have positive X pointing into the spindle and negative X pointing out of the spindle. Spindle will be over here. There are three different types of fourth axis work that we'll do typically in here. The first one is indexing, and all that is conceptually, it'll rotate the stock to a specific location and then you just do 2D operations like normal. The next one is a 2D wrap. That's taking a traditional 2D operation and wrapping it around some rounds. So these two grooves right here, if you didn't already do them on the lathe, which would probably be a better idea, you could do them on the fourth axis by doing a contour or a dynamic mill and then wrapping it around. We'll talk more about that once we get there. The third is a rotary toolpath, and it is what we think of as traditional fourth axis. It's more like a 3D surfacing operation that uses the fourth axis rotating. That one is a lot more of an art than a science, just like 3D surfacing. So let's get going. We need this guy. Great. Man, it is struggling. Good. Do this. Oh man, guys, this is killing me.
I don't know if it's gonna affect the video, but all I can see is you click on bounding box.
It is? Oh, okay. Well, we'll wait for it to update. Turner, could you grab that real fast? Thank you. Logan, could you let me know when you can see the screen? It's taking forever to update.
Yes, I'll let you know.
What are you seeing right now?
I see the stock box.
Mm,
Like your mouse is hovering over a bounding box.
Yeah, you can see it on our screen also.
oh man, that's not even what we're doing. Okay, I'll hit escape.
Oh, there it goes.
Okay, take two. Let's see if that works. Stock setup, bounding box.
Ooh, it does not like bounding box.
No, it does not. That's chill. We'll just not do that. Display cylinder. I don't know what size this is. Like a, I have no idea.
Well, you can still set up bounding box. Remember, we're assuming you already know how to do that kind of stuff.
Yep, but just
Oh, there we go.
we'll do it manually.
Nice.
Ooh, that's close, but still wrong.
We're doing additive manufacturing too.
We'll just call it 5 inches and 1 inch. Sure. Ah, yes, that's actually correct.
Beautiful.
Okay, so we got our stock. Traditionally, I put in all of my datums right now and all of my tools right now, but I want to explain that as we go. So I'm going to refrain and we'll just do it along the way. But I will add, just one tool, maybe this guy. Yeah, that'll be fine. And then this guy, and then I assume those are 1/4 inch holes. Oh no, 3/16. This thing needs to move. I'm curious what it does and does not show. Can you see the dialog box I'm working through right now, Turner?
Yeah.
Cool. Yeah, apparently not. Let's just call this tool 4. Okay, so that's enough for us to get started. We'll do the indexing first. This one is the most straightforward toolpathing wise, but involves a little bit of thinking with your datums. When it comes to indexing, let's say that we were going to do this surface and then this surface with the bull nose, just as a traditional 2D pocket. Or I'll probably do a peel mill for this. I can use this first datum. Let's switch to levels so we can see this first datum with Z pointing up will work just fine for this. But I need to rotate the part 180 degrees to do this one. So the way that that's accomplished in MasterCAM is you take and make a new datum in the same location as your original datum, but then you rotate about whatever your rotary axis is. So in this case, we'll be rotating about X, and you point your Z in the direction that you want to be up in the machine. So I'm going to name this plane Index 1. Check. So go ahead.
So, in my research, if you have dynamic work offset in the middle, you don't necessarily need to put the data about the rotation point. Do we have that in the VF4?
I don't know if we do. I haven't ever tried to explore it. I have always had the best results doing it this way. We've run into issues before with the posting not working correctly, so I don't want to venture into even more complicated stuff before we tie this down.
Gotcha.
But for now, let's just say that you need to put it in the same spot and then rotate it about the rotary axis. There are other ways to do this.
Okay.
For the first toolpath, we'll come in here and leave it on top right here, which is our first setup. Real quick, we'll just add a peel mill, this button, and this button. Good. Good. We're not going to worry about feeds and speeds at all today. Okay, calm down.
What part of this piece are we working on?
We are working on this flat for the whatever bolt's going through.
Okay, cool.
My mouse is out. We're just going to flatten that out. Okay, absolute 0.1. Let's say that this has already been turned down to the major diameter. Depth right here. Good. So, man, this is way smaller than I thought it was. Yeah, no, that's not gonna work. That's fine. We'll cheat. Okay. So that will cut that slot the way we want, and account for the bull nose radius. So those chamfers won't be cut, but they'll have a radius that's from the bull nose. That looks like, oh, this is going to be interesting. Can you see that? Ah, bummer. Okay. Oh, okay. Here we go. Oh, sweet.
Oh, here it comes.
Yeah, this computer's struggling. So that's what that did. It cut the flat perfect, but then just left the radius there instead of doing the chamfer, which would be fine for what we're doing. So let's say that we want to do that again on the other side. What you do is you come to your planes, and instead of just clicking on index 1 and hitting equal so everything changes, you want to keep top as your work coordinate system. So the original work coordinate system should never change for indexing on the 4th axis, but your tool and construction planes should both be on the new datum with Z pointing up on the plane that you want to work off. What this will look like in the G code, just so you're aware, is when it posts, you should not see an incrementing work system. It should not be G54, G55, G56. It should all be G54, but it'll have callouts for the 4th axis, which are an A and then some degree value for it to rotate. So in this case, if I wanted to verify my G code, I'd look for an A180 because it'd be going 180 from the original location. And typically it'll assume that your original datum is A0.
Now, question: like if we had multiple axes, so we got an A and a B axis. If we had a B axis rotation, we'd just call out B and then whatever degree.
I assume so, but we don't have one, so I have no idea. No, I've never used 5 axes, which would be fun, but this will just be for 4. All right, so I'm gonna go in, and because I'm lazy, I'm just gonna copy this toolpath and go in to the parameters, planes, and instead of top, I'm just gonna manually adjust that to be index 1, push that across. And because it's in a perfect mirror, all of my settings will actually work. I don't need to go reselect the geometry, which is convenient. Okay, so if we grab both of these, good. And that will post correctly so long as you have your plane set up with your original work coordinate system here, and then whatever index you're on in the tool and construction planes or compensation plane. All right, so let's see. Any other notes on that would be your linking parameters are just like they would be for any 2D operation based off your datum. In our case, it's off the center of the stock, so none of these are 0 or negative. Now would be a great time to drill that hole. If that's what we were doing, we would do the same sort of thing, index, drill the hole. But we're gonna move ahead and do a wrap operation.
Quick question though.
Yes.
For indexing, this is probably a good time if you're worried about the part when it's rotating, crashing into your tool to use clearance planes, correct? Like if you're gonna index between an operation.
Yes, but our retract plane is higher than the major diameter,
Gotcha.
so it doesn't actually
That's
matter.
probably something to be aware of though. If we are indexing, if you have a small feature that's gonna come into contact, make sure you're out of the way.
I would always just put your retract plane high enough that it clears the part regardless, but you could use a retract plane that's low and a higher clearance plane if you'd like. What's up, Logan?
What?
I have a question about the linking parameters.
Yeah.
Are those numbers, is that the radius of the major diameter of this part, assuming it's been turned down? Or is that the diameter?
It is the
I assume we're basing it. So that's the diameter?
So I made a comment earlier that probably was confusing, but we're going to assume they have turned this section down to what we're looking at. And the radius of the model right here is 3/8. So the radius over here.
Okay, no, so that answers my question.
Yeah, the radius over here with the weird deflated airbag shape is 0.5. So this wouldn't clear that, but because we're over on this section that's been turned down, it's fine. So
now would it so if we turn down this part on the right hand side of the screen to 0.375 with a 0.375 radius, but the left hand side had a radius of 1/2 inch, would the tool crash as it went over there?
If it went over to this section, yeah.
So we're holding on to it from the right hand side of the screen, right?
Correct. We're clamping on this section that I'm highlighting.
No, but never mind. I see where your traverse lines are, and it's not going to crash. I can see that.
Yeah.
Cool.
If you come in here and add a clearance plane of 0.6, that'll clear the major diameter even over here where it's bigger. The retract plane is high enough for this section though.
Got it. That makes sense.
All right. So let's just, so we don't get confused, we're gonna go here and call this indexing. Then I'm just gonna make a new group. And this will be wrapping. And then one more. This guy will be rotary. Okay. So to wrap a 2D operation, it's a little more involved, but you don't have to mess with your datum typically, which is nice. So let's say we wanted to cut out this slot right here. I'm going to grab a tool that's a lot smaller so that we can actually 3/8. Okay, we'll grab a 1/4 inch so that we can do a dynamic there. Let's see, 1/4 inch. Okay. You go select your toolpath just like normal. But if I wanted to cut this slot, I can't select geometry that overlaps itself in the Z direction. So something round like this won't work. So I'm going to pause and instead come in and draw some geometry in. First, I need to know the radius of this surface. So click on this guy here, and it's, I'm going to write this down, 0.3125 radius. And the slot that we just measured was 3/8. So I can come in here now, and I should bring this over here. So, oh nice, got a pie button. We need the circumference of this, because what we're going to do is we're going to draw a rectangle that we can wrap perfectly around this surface. So the one dimension, the short dimension of the rectangle will just be 0.375, but the long dimension of the rectangle will be the circumference of this surface. So it's really hard to select, but that circle right there. So let's see, pi diameter, or 2 pi r, times this guy, times this guy, times this guy, gives us the number we need. Could someone grab that, please? Thank you. So this is the dimension that I need. So copy this, and then we'll come in and draw that rectangle. I want it to be coming out of the center of the stock. So the width is 0.375, and this is whatever we copied, and we'll make it negative just because. Okay. So now we've drawn the rectangle that if we picked it up and wrapped it around this feature, it would fit perfect, but it's originating out of the center of the part. Let's see if I can highlight this.
Sorry,
there we go.
Just a double check. I missed it. That rectangle is actually a little bit longer than the circumference, right, for overlap?
Nope, we'll get there.
Okay.
So it's perfectly the right size. Boom. Now I'll come back here and we'll add in our toolpath. Dynamic, that's my machining region. Check. And I don't need any of these other regions. I'm just gonna hit check. Change it to our 1/4 inch tool. Change this guy so we can actually get in there. This guy and this guy. Depth cuts we'll leave off for now. Entry motion, I'll do this, but it won't matter later. Okay, so this is where it gets interesting. This slot is relatively thin. So if I was doing a normal operation, it might look something like this. I'm just gonna let that render. Oh man, that's so tiny. Okay, we're gonna go get a different tool. Oh, need to project library. Yes, we have one. Okay. So the only reason I'm changing the tool right now is just to help illustrate a concept, and the way that it was doing the last one wouldn't work. Okay, cool. So we are in the wrong plane, which is good to note. You can see I put in a negative value in the linking parameters here, and it came in the direction I thought should have been up. That's because I left my indexing plane tool and construction back on index 1, so I need to change that. Changing it in my planes won't update it, so I need to come into here and actually update it, push this across. Okay, that's a good thing to note. For wrapping, you don't use any goofy plane, we'll just be using the original work coordinate system. That looks good, but, oh, it changed this. In order to wrap it, we just need to go change one quick thing. And that is, wow, that's terrible. Right in here, under axis control. There's axis combination, we don't need to worry about that. But rotary axis control is where we wrap our tool paths. It's called axis substitution. So we'll select axis substitution, and then you select which axis you want to substitute as your rotary. You can just trial and error, click one and see if it works. Or you can think about it this way, that any motion in whatever axis you select, be it X or Y, will turn into a rotation as opposed to a linear movement. So if we look at this setup, we know X is running along our part. We need X movements to be actual linear X movements. But anything Y running away from the part, parallel to the radius, can be a rotation. So we'll be substituting Y in our case. It asks, when would you substitute X?
If you always use the X-axis.
You would only substitute X if we had moved the fourth axis. So in our case, you'll keep almost always substitute Y. The rotary diameter and your linking parameters become a little bit complicated. To be totally honest, usually what I do is I trial and error this because I forget. I don't do it often enough. I have to go, oh, how was that? And I'll like type in some guesses and then figure it out again. So we're gonna do that right now. I'm going to put in the rotary diameter of that feature. And that feature's diameter is 0.3125 times 2, which is this guy. And then I'm going to just leave these linking parameters. It's not. I'm going to leave these linking parameters as they are. And we'll just see what happens. Okay, cool. Good. That's actually not half bad. So I'm going to change my depth to be 0. My top of stock to be, let's say, just a 16. The feed plane to be this plus a 16. And then the retract plane, I'll just make a 1/4 inch for now. So this should wrap correctly. Good. What's happening is because I have used a rotary diameter that matches this surface's diameter, I can put the linking parameters at a depth of 0 and it'll cut to 0 or to the surface. Alternatively, you could come in and put in the rotary diameter of the full part and then have your depth be driven off, oh man, actual features. So I need this guy. Good. And then I need this guy. And then 0.375, 0.01, 0.475. Well, let's make it 0.6. Okay. So there's multiple ways to accomplish the same thing. Gotta do a negative. Let's see, that would make it So what this has done is now all of these values are relative to the surface of my round, the original stock definition, because I've told it 1 inch. So if I wanted to do it this way, as opposed to the first way that I showed you, we would come in, we would measure the distance from the center of my round to the top of the part, which is right here. And in Z, that's 3/8. So we can come in here. My final cut depths will be 0.5 minus 3/8 or 1/8. Oh, man. Oh, thank you. Very important. But it's going to be a negative value because we're coming in from what is now 0, or the top surface of the stock. Top of stock, I'm going to say is, oh no, sorry, this should be top of stock. There we go. And then this guy, minus 0.065. Feed plane 0.01, retract blade 0.1. I'm not sure about that depth, if that's correct, but everything else should be correct. Okay, good. Slick.
Why is it only wrapping halfway around?
Yeah, I will show you now. I don't love using the method I just did. I actually prefer putting my rotary axis to be the diameter of whatever surface I'm at, and then putting my linking parameter depth as 0. But, oh, I know. 0.3, 0.4. And I'll show you why, to answer your question, Cam. Sweet. So there's an issue that's inherent with wrapping. If I wrap this 2D operation onto this part perfectly, there's still a gap. And it was a lot bigger in the one we just looked at, right?
Yeah.
But that's because, how to put this into English well. I think I know how. So if I unwrap this real quick and we look at it. From your CAM experience, you already understand that it won't cut this corner well.
Yeah.
So you're going to have an issue when we do wrap it, that they won't overlap in the corners, which is to be expected. But if we run the render on this, you'll see that they don't quite match the way we're hoping, even on the flat edge. So fast forward, it's coming around. Sweet. So they don't match. If you look at the pink right here, those corner radiuses don't cut the part fully. And then there's this funny section in the middle that's just not cut at all. If I zoom in here, it is actually cut perfectly at the surface of the part.
Because it goes like, it makes like a pizza.
It makes like a pizza shape. You're right. So let's see if I can get a good view on this. No, we're not going to get a great view on it. So that's probably the best we'll get. Right here, there's this wedge shape that is not cut out. That's because the tool is always coming in perpendicular to the part or parallel to the radius. So in order to actually cut the full part, we need to over-rotate or overcut. Turner, you mentioned this earlier. This is that problem. There's a few ways to solve this problem. One way I like is to just use a peel mill because it won't give you this corner problem. It will make sure it cuts all the way. But regardless, whether you use a dynamic pocket or a peel mill, you actually have to extend this guy further to account for this artifact that I just tried to describe with English, which is really hard to do, but a lot easier to just look at. So we're going to go back into our part. I'm going to leave it as a, oh man, struggle bus. What's your screen showing?
This, that.
Okay.
Oh.
Oh no!
No,
Image
no.
crashed, and we didn't save it. Oh well. Good news, we have Logan's when we did this before. So we're just gonna open up TCAM. Cam practice T. All right, wow, check it out. Bunch of stuff's already done. I like that. All right, to bring you up to speed with what we did on this one, we wrapped this large rectangle to get the height down on the entire part. So we were not assuming it was turned down on this time. Let's go ahead and just redo, well, we'll leave it. All I was going to do for that last one was make this portion of our rectangle longer to help accommodate for that overlap. So if we look at this toolpath that's highlighted, you can tell if you're experienced looking at toolpaths that they're overlapping. It looks like it's overcutting, which it is on the surface of the part. But if you zoom out to the surface of the stock, not the surface of the workpiece, they're not overlapping that much. So if we run the render on this guy, and this computer's struggling, and we run just that toolpath that we have. I'll do this. Man, this computer does not like running Zoom and MasterCAM renders. There we go. So it cut far enough that there's no pizza-shaped artifact left over. It overcut that section. So that's something you have to watch out for wrapping. You need to make sure that you extend your 2D region that you draw that matches your profile far enough that you don't get that funny overlap on the surface of the part. In theory, you just need it to cut perfectly at the surface of your workpiece, because then that wedge-shaped part will fall off if it's not attached on the walls. But if you're in a groove, you do need to overcut it all the way. Before we go into the last one, which is rotary, are there any questions? Logan, you have your hand up. Is that just from earlier?
Oh, yeah, my bad.
Okay, I got it.
I've got a question.
Yeah, go ahead, Cam.
So you calculated the circumference. I didn't see at which point you incorporated it.
That's a good question.
I don't know.
I incorporated the circumference into this length right here.
Oh, the
This highlighted line.
But then you ended up having to.
But then you end up having to make that line longer than the circumference because of that artifact where it leaves like a wedge shape and you need to overcut.
Do you know, like what's the trick for knowing how much to overcut? Just like the radius of the tool or something?
I don't know a good trick, to be totally honest.
All right.
I usually just go, yeah, that's probably enough, and then it works.
Sweet.
I'm sure there's a way to do it that makes more sense, but I haven't spent the time to try and figure it out. Turner, do you have any questions?
No, that made sense.
Okay. Logan,
kind
you're
of
good.
explained that one to me, so that makes sense.
Okay, so for this one, there's no one right way to accomplish it. You just need to make sure that you're using axis substitution, substitute Y with our setup, and then have some rotary diameter. For this one, we actually used the rotary diameter of the original stock and then adjusted our linking parameters from there. Yeah, there's no one right way to do this. If you have questions about it, the best way to answer them is to just start playing with it, and you'll start to understand better how rotary substitution or axis substitution and your linking parameters interact. They're hard to put words to, but once you mess with them, it actually makes a lot of sense.
It's a matter of knowing which buttons you have to push to learn how to mess with it.
Not so much which buttons to push, but how the linking parameters are interpreted when you use a rotary substitution, where your new 0 becomes your new Z0 essentially, based off that. So as an example, real quick before we move on, the depth on this cut is that value. Top of stock is 0, and then retract is 0.1. And if we look at our part, oh gosh, yeah, about like that. This height is 0.1, so it's interpreting the linking parameters with a Z0 of the surface of the stock, because we went in and said rotary diameter is the diameter of the stock. Okay, let's go ahead and move on. We're going to add a new group. We're going to call this guy actual rotary. Ooh, I hope the license on this computer works.
Sure.
We will find out real soon. Okay, so in summary, we've done indexing, wrapping, and now the last one is rotary. It is not under 3D because 3D only relies on 3-axis. It's actually under multi-axis, although it is very similar to 3D. We'll click here on rotary. Ah, lousy. Okay, we're gonna have to move computers to, I believe the one that Cam is on has.
You can just share this screen, and then you can still use that video or whatever. I don't know. No one doesn't have the microphone, so I guess.
Yeah,
you can
we'll
talk
just have to move the mic.
Yeah, whatever. You wanna do.
Would you pull up the, here, let's toss you my flash drive.
Hold the part.
Okay,
Yeah, you just go. I'm just-
actually, you know what? We'll just make this a 2-part video. That'll be part 1, and then I'll start a Zoom call from that computer once I move the mic and everything, and we'll do rotary. So this video actually only covered indexing and wrapping.
Yeah.
Yahoo!
Best video ever.
Greatest video. Okay, we'll end this, and then we will jump back in on the call once we move computers. Thanks, everybody.
Cool, cool.